Hey guys, so today we're going to talk about arithmetic sequences. So our learning targets for today are: I can determine whether a given sequence is arithmetic, I can find the common difference of an arithmetic sequence, and I can write an expression for an arithmetic sequence and calculate the nth term. So the first thing we need to do is we need to identify some definitions that will help us get through this unit. So the first term is a sequence. That's an ordered list of items. Missing an S there, sorry. An arithmetic sequence is a sequence in which the difference of a consecutive term is a constant, meaning addition or subtraction. A sub n, you're going to hear me say that a lot. That means the nth term in the sequence. And the common difference, and you'll hear us call that D, is the constant difference between the consecutive terms. If you need to pause the video to copy down these definitions, please do so now. Okay, moving on to our examples so we can identify some of these definitions. You see that you're given an arithmetic sequence 4, 6, 8, 10, 12, 14. So I have an arrow pointing to 8 and I've labeled that as A sub 3. The reason why is because if you count 4, 6, 8, 8 is the third term in the sequence, which means it gets the notation A sub 3. Now the other term we need to talk about is the common difference. So you can see I've boxed in two numbers, 10 and 12. Those are consecutive terms because they're right by each other. So we notice to get from 10 to 12, you add 2. Therefore, that means that the common difference, or D, is equal to 2. Okay, moving on. Finding the common difference. So we know that the common difference is how you get to the next term in the sequence, like how we got from 10 to 12 in the previous example. So a formula to represent this, you need to remember that A sub n is the nth term in the sequence. And you can see that formula right below there. So it says that D equals A sub n plus 1 minus A sub n. So don't be overwhelmed by all of those variables and subscripts and things like that. So if A sub n is one term, A sub n plus 1 is just the next term. So if we have A sub n and it's the second term, A sub n plus 1 would be the third term. It's just the next term in the sequence. So we are going to do an example for this. So it says our sequence is 5, 4, 3, 2, 1. So we're going to use the formula. You can pick out any two consecutive terms. It could be 5 and 4, it could be 4 and 3, 3 and 2, or 2 and 1. Doesn't matter which pair, it'll give you the same answer either way. So I picked 3 and 4. So what you do is you subtract left from right. So I'm going to do 3 minus 4. And that gives me negative 1. So that means that my common difference is negative 1. So every time I move to the next term, I'm going to subtract 1. Okay, moving on. So I want you to take a second and decide if these following sequences are arithmetic or not. So go ahead and pause the video and write down your answers. Okay, welcome back. So, number 1, it says 3, 4, 5, 6, 7. So we need to decide if that's arithmetic or not. What we need to look at is that common difference. So from each term to each term, am I going up by the same amount? So from 3 to 4, we went up 1. From 4 to 5, went up 1. 5 to 6, went up 1. 6 to 7, went up 1. So it's safe to say after about 3 times of going up consecutively, you can assume that it continues on. You don't have to worry about it changing all of a sudden. So you should have said yes for the first example. Number 2, 1, 3, 4, 6, 7, 9. So you see here, when we go from 1 to 3, we go up by 2. 3 to 4, we only go up by 1. So right off the bat, you know it's not arithmetic, because for it to work, it has to be the same exact difference every time. So we should have said no for number 2. All right, number 3, 25, 20, 15, 10, ... That just means it keeps going down. So we check. 25 to 20 goes down 5. 20 to 15 goes down 5. 15 to 10 goes down 5. So that is arithmetic. Our common difference would be -5 or -5. So you should have said yes for number 3. Okay, moving on. All right, recursive formula. So our first formula of this unit. Great. All right, so recursive formula, we're not going to use it too much, but it is useful to know. It's almost like the common sense formula. So it says when you're going to use this when you're using a term and the common difference to find the following term. So you see that definition I gave you there, the formula, a sub n minus 1 equals a sub n plus d. So our example is 1, 3, 5, 7, 9. It asks us to find a sub 6. So take a second and make sure you realize why we don't already know a sub 6. So you can, if you count there, 1, 3, 5, 7, 9. We only have the first 5 terms. So a sub 6 would be the term that comes directly after 9. So it says step 1, you need to find d. So to find d, remember you pick any 2 consecutive terms. Doesn't matter which 2. I picked 5 and 3. So I do left minus, no, I do right minus left. So 5 minus 3, which is 2. So my common difference is 2. So if you need to take a second and rewind and make sure you realize why our common difference is 2, go ahead and do that. Okay, we're going to go ahead and move on. So step 2, it says using the previous term, a sub 5. The reason it's previous is because we're looking for a sub 6. Use a sub 5 and the common difference to find a sub 6. So you can see my work there. It says a sub 6 will equal a sub 5 plus d. So a sub 6 equals 9, which is a sub 5, plus 2, which is d. So a sub 6 is 11. So you just solved for a sub 6 using the recursive formula. Okay, moving on. Almost done. All right, explicit formula. And this is a formula used to calculate any term in the sequence, which is why it's so great. You can calculate whatever term you want. So you see the formula there. It's a sub n equals a sub 1 plus n minus 1 all times d. So where it comes from, because I know you guys don't just want to trust me about these formulas. We want to know why they happen, right? So I give you the example, 4, 6, 8, 10, 12, 14, ... So it keeps going. So we know a sub 1, the first term, is 4. We know that the common difference is 2, because each time, to get from 4 to 6, 6 to 8, 8 to 10, 10 to 12, we go up by 2. So if you notice when I lay out each of these terms, so now when I try to calculate a sub 2, that's 4, my a sub 1, plus 2. A sub 3 is 4 plus 2 plus 2. Does that make sense? So 4 plus 2 plus 2 gives me my 8. 4 plus 2 plus 2 plus 2 gives me my 10, so on and so forth. And you can kind of see there on the right side of those equations I've bolded that ends up being 4 plus 2 times 1. 4 plus 2 times 2. 4 plus 2 times 3, which mimics the formula that I gave you. Okay, moving on. Alright, so I want you guys to try to put this formula into motion. So I've given you 3 questions. I want you to go ahead and pause this video and try to work them out as best as you can. Okay, welcome back. So we are going to go over the answers to those 3 questions that you just tried to work out. So in question 1, it says find the 50th term when a sub 1 equals 7 and d equals -2. So because it's the 50th term and it's nowhere near the beginning, we definitely want to use explicit formula. You don't want to take all that time punching in your calculator 50 times. So what we're going to do is we're going to plug in what we know. So we know that we're looking for the 50th term, which is a sub 50, and that equals a sub 1, which is 7, plus n, which is the term number, so 50 minus 1, times d, which is negative 2. So if you put that in your calculator, you should get negative 91. Okay, question 2. Find the 28th term of the arithmetic sequence given. So again, it's not really close to the beginning. 28 is pretty far off, so we're going to use the explicit formula. We know a sub 1 is 3, and we can calculate d by doing any two consecutive terms and subtracting them. So I picked 7 and 3. So 7 minus 3 is 4, so d is 4. So now I plug in what I know and I simplify. So I'm looking for a sub 28, because that's the 28th term, equals a sub 1, which is 3, plus 28, which is my term number, minus 1 times 3. And you should get 111. Alright, question 3. This was the tricky one. So this says which term, and I put a sub question mark to try to help you out there, in the sequence given is equal to 72. So we're no longer trying to find the value of a term. We're trying to find when it happens. So if you see my little sidebar there, when you have a question asking when or which term something happens, you're actually going to be solving for n in the equation. So the first thing we did was identify a sub 1 and d. So a sub 1 ended up being 15, and d, you should have had to calculate it. So I picked 18 and 15. 18 minus 15 is 3, so d is equal to 3. And we already know the a sub n value that we're looking for. So that nth term is equal to 72. Okay, so when we plug this into our formula, I shouldn't have a sub 72 equals. I should have 72 equals 15 plus n minus 1 times 3. So the thing we don't know is which term it happens. So we know the answer is 72. We just want to know, is it the 10th term or is it the 15th term? That's what we're trying to solve for here. So once you get that formula set up, it's just solving for n. So you see my first step, I distributed the 3, and I got 72 equals 15 plus 3n minus 3. I combine like terms on the right side, so 72 equals 12 plus 3n. Subtract the 12 and I get 60 equals 3n. You can ignore that box there, it was supposed to be an arrow. And then once I divide by 3, I get n equals 20. So 72 is the 20th term in that sequence. Alright guys, so that's all we have today. So come into class tomorrow ready to ask questions. We'll have a worksheet or some type of activity to go over the stuff that you watched tonight. Okay, I hope you enjoyed this. It's something different. Bring feedback and questions tomorrow. See ya.